Good evening, children.
Good evening.
Good evening. Good evening, children.
Good evening.
Good evening. Let's revise this answer again. So how do we represent the information diagrammatically? We'll see now. So 3 girls, Reshma, any order? I think we took it like this last time. 3 girls, Reshma, Salma, and Mandeep, are playing a game by standing on a circle of radius 5 centimeters. Reshma, Salma, and Mandeep are playing a game by standing on a circle of radius 5 meters drawn in a park. So the girls are standing on the circumference of the circle like this. The radius of the circle is 5 meters. Reshma throws a ball to Salma. Salma to Mandeep. Sorry, let me do it again. Reshma to Salma, Salma to Mandeep, and Mandeep to Reshma. If the distance between Reshma and Salma and Mandeep is 6 meters, 6 meters. RS is 6 meters, SM is 6 meters. What is the distance between Reshma and Mandeep? So we need to find RM. RM is equal to question mark. We need to find the length of the line segment RN. That is the distance between Reshma and Mandeep. So children, construction, join OM, 5 meters is the radius. Join OM, also join OS, also join OS. I told you that to find the length of the line segment RM, let's say when you join OS, it intersects RM at, let me see what I've taken here, N, okay, N. Okay, so when you join OS, it intersects RM at N. Okay, so how are we going to find RM? How are we going to find RM? This is what we're going to do. We're going to find MN. We're going to find MN, double it to get RM. We're going to find MN. And then we're going to say twice MN is equal to RM. But how is that possible? That's possible only if N is the midpoint of RM. Only if N is the midpoint of RM. So you must show that MN is equal to RN. You must show that MN is equal to RN. MN is equal to RN. That is, you need to prove that N is the midpoint of MR or RM. N is the midpoint of RM. Also, you need to prove that SN is perpendicular to RM. You need to prove 2 things. N is the midpoint of RM. And this angle here is 90 degrees. That is, SN is perpendicular to RM. And this can be achieved by proving that these 2 triangles are congruent to each other. Once you prove that these 2 triangles are congruent to each other, CP/CTC, Rn of this triangle will be equal to Mn of this triangle. And this angle will be equal to this angle, CP/CTC. But they form a linear pair. These 2 angles are equal, but they form a linear pair. Rm is a straight line. Okay, so they form a linear pair. So that means they have to be 90 each. So each angle has to be 90 degrees. So we have to prove that this angle is 90 degrees and also prove that Rn is equal to Mn. These 2 results can be achieved by proving that triangle RSN RSN is congruent to MSN. MSN. Now let's see the information, the equalities available to show that these two triangles are congruent to each other. What are the equalities available to show that these two triangles are congruent to each other? So we know that RS of the first triangle is equal to SM of the second triangle. RS is equal to SM. RS is equal to SM because it's given that each of them is equal to 6 meters. Then SN is equal to SN common side. SN is equal to SN common side. Yeah, SN is the side common to both the triangles. Okay. If you look into the two triangles further, you will see that there is no more equality in the two triangles. That's all. We have only these two. You please think about it. OK, you also check. You will see that there are no more equalities. There are no more equalities. No angle of the first triangle is equal to any angle of the second triangle, or no side of the first triangle is equal to some side of the second triangle. You don't find any more pair of equal sides or equal angles. So we need to, find out something else before we prove that these two triangles are congruent to each other. Before you start that, you need to get one more information. So since we have these two equalities, since we have these two equalities, RS is equal to SM, that is this side is equal to this side, and this is the common side, we can prove that this angle is equal to this angle so that it will make the SAS congruence rule. So we need to prove that this angle is equal to this angle. These two angles are equal. These two angles are equal. We need to prove that these two angles are equal. Now, one of you will repeat the proof. One of you will repeat the proof. Listen carefully. So since we don't have sufficient information to show that RSN is congruent to MSN, we don't have sufficient information to prove that RSN is congruent to MSN. We don't have sufficient information. So we need to have one more equality. We need to find one pair of equal angle, this angle equal to this angle, so that you can use the SAS congruence rule and show that the two triangles are congruent to each other. Now, when you look at these two angles are made by the equal chords RS and MS with the line passing through their point of intersection and also joining the center. We have seen a result like this. When two equal chords intersect within the circle, when two equal chords intersect within the circle, when two equal chords intersect within the circle, they make equal angles with the diameter. They make equal angles. If you produce this as the diameter, you produce this because if you produce a radius, it's a diameter. Okay. So when two equal chords intersect within the circle, they make equal angles with the line or with the diameter passing through their point of intersection. The statement is, or the result is, when two equal chords intersect within the circle, they make equal angles with the diameter passing through their point of intersection. Okay, so this is the diameter. Let's say this is the diameter. So the center O lies on it. The center O lies on it because it's the diameter. So let's say that this is the diameter passing through that point of intersection. When two equal chords intersect within the circle, they make equal angles with the diameter passing through their point of intersection, which means this angle is equal to this angle. So you can apply this result here because RS and SM are two equal chords, each of length 6 meters. They intersect within the circle, meaning they intersect on the circle here. And you can see SO is the radius. SO is the radius. If you extend it, it's the diameter. So S is the point of intersection. S is the point of intersection of the two chords. And through the point of intersection, there's a diameter. So this angle is equal to this angle. You can use that. You should state that. You must state that result and then write. If you number it, angle 1 is equal to angle 2. You should state that. You should not simply say angle 1 is equal to 2. So you must write out that result, meaning that statement, and then say angle 1 is equal to angle 2. Otherwise, you have to join RO and take up the triangles SRO and SMO. Otherwise, so if you don't want to remember, see, I shouldn't say that, but I'm just telling you, in the worst case, you don't want to remember the result. Okay, so then what is the alternate method? See, not always you have an alternate method. You don't want to remember something, so tell me an alternate for that. No, it's not like that. I'm just telling you the alternate approach here for this one because it's available. So if you forget, okay, let me say, not that you don't want to remember, say you just forgot the statement, you're not able to recall, then what to do? So then you have to join RO and take up the triangles SRO and SMO and show that the triangles are congruent to each other. See, I've written it down here, SRO and SMO. SRO, SMO. Take up these two triangles. So to have the triangle SRO, children, am I audible and clear?
Yes, ma'am.
Yes, ma'am.
All right, children. Thank you. Thank you, children. So take up the so to have the triangle SRO, we need to join RO. So we join RO, and then in triangle SRO and SMO. Yes, Shivani, are you there, Shivani? Please tell us how are these two triangles congruent? Shivani there. Yes, Shivani is there. Arav, Nikita, one of you tell me. Shivani, one of Shivani, Arav or Nikita, volunteer. How do we show that SRO is congruent to SMO? Very simple. So you will feel bad if you don't answer because it's very simple. It's all there. You just have to take the initiative to think. That's all. Little thinking, you'll get it. If you simply stare at the figure, there's nothing. Just take a little effort and think you have it. How do you show that SRO is congruent to SMO? The equalities are right there. Look at the sides, look at the angles. Or look at the sides. Let me make it very simple. Look at the sides. Some side of the first triangle is equal to some side of the second triangle. Quickly, Nikita, Arav, Shivani. Who wants to try this? Tarun Ishwaran. Who wants to try this? Nobody. You must.
Ma'am, can I?
Yes, who's that?
Kanishka.
Yes, Kanishka. Please go ahead.
Ma'am, RS is equal to SM, ma'am.
Yeah, correct. Why is RS equal to SN?
Yes, because they have the same centimeter, ma'am. Sorry, same meter, ma'am.
Yeah, very good. They have the same length. Very good. Next.
And then RO is equal to MO, ma'am.
RO is equal to MO. Reason?
The same meter, ma'am, 5 meter.
Because both are the radii of the circle. Correct?
Yes, yes, ma'am.
Correct. Next.
And then SO is common, ma'am.
Very good. SO is the common side. That's all. See, little thinking. That's all. You know, the others cannot say that it was difficult. You definitely cannot say it was difficult. It's all there. RS is the RS of this triangle. See, the triangles are SRO and SMO. RS of this triangle, the first, let me call this the first triangle, this one the second triangle. RS of the first triangle is equal to SM of the second triangle. Somebody's mic is enabled. Please disable your mic. 6 meters. Then RO of the first triangle is equal to MO of the second triangle. Radii of the same circle. SO is equal to SO, common side. So by SSS congruence criterion, the two triangles are congruent to each other. CPCTC, angle 1 is equal to angle 2. In two congruent triangles, the corresponding angles are equal and the corresponding sides are also equal. So angle 1 is equal to angle 2. Wasn't that easy? Yes, it was easy. It is easy. All right, children. So this is the alternate approach. If you don't want to state that result and write angle 1 is equal to angle 2, take up these two triangles and show that they are congruent to each other. So by SSS congruence criterion, angle 1 is equal to angle 2, CPCTC. And then which are the two triangles to be taken up? After that, once you get the result, angle 1 is equal to angle 2, which two triangles will you take up? Now we got the result angle 1 is equal to angle 2, either through congruency or by stating the result. What's the next step? We need to take up two triangles and show that they are congruent. Which two triangles?
Yes, RSN and MSN, ma'am.
Very good. RSN and MSN. We need to take up RSN and MSN and show that they are congruent to each other. Yes, tell me the equalities, Kanishka.
Ma'am, RS is equal to MS, ma'am.
Yeah, then
now we proved that angle 1 is equal to angle 2, ma'am.
correct.
And SN is common, ma'am.
SN is the common side. So what's the congruence rule?
SAS, ma'am.
By SAS rule, the two triangles are congruent to each other. So what are the results you are interested in through CPCTC?
Ma'am, RN is equal to MN.
Yeah, you want to prove that N is the midpoint because we need to find the length of the line segment RM. We need to find RM. This is what we need to find. So if we prove that N is the midpoint of RM, instead of finding RM, we can find MN. We can find MN alone. We can find MN alone, double it and get RM. Or we can find Rn alone, one half. To find Rm, if you prove that N is the midpoint of Rm, then it's easy. You can find one half of it and double it to get Rm. Okay, so Rn is equal to Mn. Then what's the next information? Through congruency. Yes, what's the next thing? See, sometimes this question is asked directly. You know, your term 2 exam. I mostly find 5th and 6th one, just ask straight away without any changes, which is why I wanted to revise. So you should say angle SNR is equal to angle SNM. All right. SNR.
But why do we need to prove that those two angles are equal, ma'am? We just need to find that the RM only, no, ma'am.
Correct. Yeah. So the answer to this question will be answered shortly. You will get your answer shortly. See here. So SNR is equal to SNM. SNR is equal to SNM CPCTC. But do you agree with this result, Shreyas? Is SNR equal to SMN?
Yes, ma'am.
Okay, you agree with the result. What is the reason?
Ma'am, it's the corresponding parts of congruent triangles of triangle SNR and SNM, ma'am.
SNM. Okay, very good. Okay. How did we prove that SNR is congruent to SNM? How did we prove that SNR is congruent to SMN?
Ma'am, do I have to list out the equalities?
The equalities, correct, yes.
Ma'am, SR is equal to SM since both are 6 meters, ma'am.
Very good.
Ma'am, in triangle SRO and in triangle SMO, we have already proved that angle 1 is equal to angle 2, ma'am.
Yeah, correct.
Ma'am, and SN is the common.
Very good. What's the congruence rule?
Ma'am, the congruence rule side angle side.
Side angle side. Okay, fine. So now SNR is equal to SNM. Let me just make it simple. Let me call it angle 3 and angle 4. Angle 3 is equal to angle 4. Yeah, just want to draw it again. Yeah, this is 1 and 2, right? Let's call this 3 and 4. So angle 3 is equal to angle 4. Angle 3 is equal to angle 4. CPCTC. But what is angle 3 plus angle 4 equal to? 3 and 4 lie on the straight line MNR. MNR is a straight line. So the sum of angle 3 and 4 will be angle 3 plus 4 is equal to
180 degrees, ma'am.
Yeah. What will be the next step after this?
Angle 3 plus angle 3 is equal to 180 degree. Ma'am, as angle 3 is equal to angle 4. Ma'am.
Correct. Next.
Twice of angle 3 is equal to 180 degree. Ma'am.
So what is angle 3 equal to?
90 degrees.
90 degrees. So we have proved that this SO, or you can say SN, SO or SN, is the perpendicular bisector of MR. Because we have the two results, angle 3 is equal to 90 degrees and also MN is equal to NR. MN is equal to NR. So perpendicular bisector. SO is the perpendicular bisector. SO is the perpendicular bisector of MR. Or SN. SN is the perpendicular bisector of MR. Now, how is this useful? Yes. The next thing we have to do is to find the area of this triangle. To find the area of this triangle using Heron's formula. Let's do that. As we do it, we'll, this question will be answered. Shreya's question will be answered. Now, the next thing is we'll have to show that triangle SMO. Sorry, we'll have to find the area of the triangle SMO. Do we know the length of SM? How much is SM? How much is SM? 6 meters, right? Yes or no, children?
Yes, ma'am.
Yeah. What about MO? How much is MO?
5 meters.
5 meters. Very good. How much is SO?
We need to find.
No. What is O? O is what? The center of the circle, right? What is OS? What is OM? How is OM
Radius,
5
ma'am.
meters?
Radius.
Radius. Radius. OM is the radius. So is OS. So is OS. OS is also the radius. OM is 5 meters. OS is also 5 meters. OS is the radius. OS and OM are the radii of the circle. OS is 5 meters. OS is 5. So when you take up triangle SMO, you know the lengths of all the three sides. You know SM is 6 meters. You know OM is 5 meters. You know SO is 5 meters. You know the lengths of all the three sides of this triangle. See, I pause so that you think. Think about it. SMO, triangle SMO. SM is 6 meters. MO radius 5 meters. SO radius 5 meters. So we know the three sides of this triangle, so we can find the area of this triangle using Heron's formula. I'll just go to the answer for the area. Okay, 12. So when you find the area of this triangle, the area is 12 12 centimeter, 12 meters square. Centimeter, I should correct it. 12 meters square. 12 meters square. Now the area of triangle SMO using Heron's formula is 12 meters square. We can also find the area of the same triangle using the formula half base into height. I want to take SO as the base. If I take SO as the base, can I the perpendicular or the altitude on the side SO is MN. Why MN is the altitude? Because this is 90 degrees, and that is why we have to prove this is 90. Only when you prove this is 90, you can take MN as the altitude when you find the area using the formula half base into height. See, first we find the area of triangle SMO using Heron's formula, because we know the lengths of all the three sides. We use Heron's formula, and the area of the triangle SMO is 12 meters square. Now we use this value of area and equate it to half base into height. Because for the same triangle, if you find the find the area using the formula half base into height, that also will give you the same result, 12 meters square. A triangle can have only one area. When you have a lot of information, you use different formulae, you cannot get different answers for area of the same triangle. Whether you use half base into height or Heron's formula or some other valid formula to find the area of a triangle, all the formulae will give you the same answer because it's the same triangle whose area you're trying to find. So half base into height also will give us the same answer, 12. When you find the area of the triangle SMO, using the formula half base into height, half into base, you want to take SO as the base. If you take SO as the base, the altitude on SO is MN only. Why MN is the altitude? Because we proved that angle 3, 4 is 90 degrees. This is 90, this is 90. So MN is perpendicular to SO. MN. See here, we have a triangle like this. This is the altitude. This is the altitude. See, this is the triangle SOM. MN is the altitude. MN is the altitude. This is angle 4. MN is the altitude on the base SO. MN is the altitude on the base SO. Yes or no, children? If you regard only for this base, you know the altitude. Now, if you ask me, what if we take OM as the base? You don't know the altitude on OM, so you don't take OM as the base. If you take SM as the base, also the altitude falls from the opposite vertex. The altitude falls from the opposite vertex. For this triangle SMO, you know only one altitude, MN, to the side SO. So you have to take SO as the base and MN as the altitude, the corresponding altitude. And when you do this, you will be able to, so that is why we need to prove that the angle 3 is equal to angle 4 is equal to 90 degrees. That's why you'll have to prove that each of it is equal to 90 degrees. Only if it's 90, can MN be perpendicular to SO. And now half into SO is 5 into MN is equal to 12. So you get MN is equal to 24 by 5. When you cross multiply 24 by 5. What is 24 by 5? 5 4s are 20.8, 4.8. Now, why did we prove that MN is equal to NR? Here we proved no, MN is equal to NR. MN is equal to NR. Why did we prove this? Because now we've got MN. It's 1/2 of MR. We found MN, which is 1/2 of MR. So you can double it. MN is 1/2 of MR. So double it. 2 into 4.8. Because, okay, let me put it like this. Since MN is 4.8. So NR is also 4.8 because we proved that these two triangles are congruent and we have this result MN is equal to RN. So if this is 4.8, this is also 4.8. Or twice 4.8 is RM or MR, which is 9.6 meters. Tell me, what's the first step? What's the first thing you'll do? We'll do everything using congruency. We'll not use that result. So first, what will you prove are congruent to each other?
Ma'am, first we will prove that triangle SRO and SMO are congruent.
SRO is congruent to SMO. For what result you want to get from that?
Ma'am, angle RSO is equal to angle MSO.
Okay, because you want this result, angle 1 is equal to angle 2. Next.
Ma'am, next we need to prove that triangle RSN is congruent to triangle MSN.
Okay, from this, what will you say using CPCTC?
Ma'am, RN is equal to MN.
And then after that, one more result. Rn is equal to Mn, and then?
Ma'am, angle SNR is equal to angle SNM.
Very good. So then later, what will you get? Angle 3 is equal to angle 4 is equal to 90 degrees, right?
Yes, ma'am.
Next, what will you do? What next, children? So we need to calculate the area of triangle. We need to calculate the area of triangle.
Ma'am, SMO.
SMO, or you can find SRO also. If you find SRO, you will find RN. Double it to find RM. Any triangle you can find. You can find the area of the triangle SRO also. Same thing you will get. SRO or SMO. We've been doing SMO. You can also find the area of the triangle SRO. Same thing. 6. This is 5 radius and SO is 5. So find the, okay, so you can find the area of the triangle SRO or area of triangle SMO. If you find SRO, you will, okay, so you'll get 12 meters square in both, 12 meters square in both. So find one of it, find one of it. So 12 meters square is the area. So if you use this triangle SRO, half into base is SO into height RN is equal to 12. Half into base SO into the height RN. Rn is the altitude because 3 is 90 degrees. If you take the other triangle, 4 is 90 degrees. Half into base SO into height Rn is equal to 12. So like this you will find. So 3 and 4 equal to 90 degrees important. Only then you can regard Rn perpendicular to SO or Mn perpendicular to SO. You can take it as the corresponding altitude. So that's why 3, 4, 90 is useful. And then Rn is equal to Mn is useful because we find we find Rm, and since we find Rn, and since Rn is equal to Mn, so like you get 4.8 here, it's the same here. So 4.8 plus 4.8 is Rm, which is 9.6. And that's what we have to find, the distance between Reshma and Mandeep. So this will give you 4.8, double 4.8, 9.6 meters is the distance between R and M, Reshma and Mandeep. I'll change this by mistake. I put in centimeter square. Have we finished this one, children? Meaning, I remember I explained this in the last class. Have you worked this in your notebook? Please complete. If you have not, please complete.
Not doing.
Come again, louder. Yes, louder.
On that day, we did not work out this thing.
No, we did not work out. You must have taken a screenshot and completed it. We did not do it in the class, that I remember. I explained it. Okay, please work it now. Not now, children. Please take a screenshot and complete this in your classwork.
Okay.
Yeah. This one. Don't do this method. I've not explained this for you. You can do this in 2 ways. I've explained only this. Please work this method. All right. Let's see the next one. A circular park of radius 20 meters is situated in a colony. 3 boys, so there it was 3 girls, so here 3 boys, Ankur, Syed and David, are sitting at equal distance on its boundary, each having a toy telephone in his hand to talk to each other. To talk to each other. Find the length of the string of each phone. Find the length of the string of each phone. All right. This one, having understood the 5th one, this should be easy for you. I'll just show you the answer. Go through the answer first. Just go through the answer, children, and just get back. All right, children. So again, this, answer can be worked in different ways. I think I've chosen the easiest. Let me see. If I make you understand, then it's easy. So again, we have a circular park. Okay, radius 20 meters. Okay, we'll show the radius. Ankur, Syed, and David are sitting at equal distance on its boundary. So that means they're dividing the circumference into three equal parts. See, they cannot be here like this. They cannot be like this, because then see this arc, the length of this arc is not equal to the length of this arc. The three boys are sitting at equal distance on its boundary. Like, for example, if the circumference of the circle is 30 meters. Okay, so then they are like sitting at 10 meters. So this length from here to here, 10 meters. This distance from here to maybe here, 10 meters. And this distance from here to here, 10 meters. So totally 30 meters circumference. They're sitting at equal distance. On its boundary. They're sitting at equal distance on its boundary. It cannot be like this. It cannot be like, you cannot mark it like this. You cannot mark it like this, because then the length of this arc, the length of this arc and the length of this arc are not equal. Three boys, A, S, and D are sitting at equal distance on its boundary. They're sitting at equal distance on its boundary. Sitting at equal distance. So supposing A is here, then somewhere here should be S, and somewhere here should be D. So the length of the arc AS, the length of the arc AS, the length of the arc AS is equal to the length of the arc SD. The length of the arc SD is equal to length of arc SD is equal to the length of the arc DA is equal to the length of the arc DA. That's what is given to us. They're sitting at equal distance on its boundary. So the length of the arc is, so supposing the circumference is equal to 30 meters, then the length of the arc AS is 10 meters. The length of the arc SD is 10 meters. The length of the arc AD is also 10 meters. So 30. And they're sitting at equal distances, 10 meters, 10 meters, 10 meters. So which means the length of arc AS is equal to the length of arc SD is equal to the length of arc DA or AD. Now there is a result which says that equal chords contain equal arcs contain equal chords. Equal arcs contain equal chords. Contain equal chords. All right. Equal arcs contain equal chords. So this is the chord. When you connect AS, this is the chord. This is the chord contained by the arc AS. When you connect SD, this is the chord. This is the chord contained by the arc SD. This is the chord. This is the chord. See, arc chord. This arc contains this chord. This arc contains this chord. So see this arc AS, chord AS, arc SD, chord SD, arc AD, chord AD, chord AD. Now since arc AS is equal to arc SD is equal to arc DA, the length of the chord AS, chord is a line segment, no? So you can use a symbol, line segment like this. We have learned in 6th standard, but we normally don't use a dots. This is how we represent a line segment symbolically. Line segment AB, ray AB, line AB, arc AB. It's a neat one, you know. I'm like, see, it's like this, arc AB. Okay, chord AB, chord. Now, chord is a line segment. So, chord with a line segment AB like this. So here, since these three arcs are equal, their respective chords are also equal. Their respective chords are also equal. That means is equal to this, is equal to this. Is this much understood, children?
Yes, ma'am.
All right, children. Tanishka.
Yes, ma'am.
All right. Yeah. So since these three arcs are equal in length, how do we know that the arcs are equal? The boys are sitting at equal distances on the boundary. So these three arcs are equal. That means they contain equal chords. So which means ASD is an equilateral triangle. ASD is an equilateral triangle because AS is equal to SD is equal to AD. So ASD is an equilateral triangle. ASD is an equilateral triangle. So somewhere here the center is located. Center is located somewhere here. Join OA, or we are dividing the equilateral triangle ASD into three smaller triangles. We are dividing the triangle ASD, the equilateral triangle ASD, into three smaller triangles by joining each of its vertices to the center O. So join A to O, S to O, D to O. We join A, S, and D to O, to the center. A to O, S to O, D to O. The three vertices of the triangle, we join it to the center. The three vertices of the triangle, we join it to the center. That is, we are dividing the whole triangle into three smaller triangles. We are dividing the whole triangle ASD into three smaller triangles. Now, now supposing we find the area of triangle 1, area of triangle 2, and area of triangle 3. Okay, so we find the area of these three triangles. In some method, we find the area of these three triangles. Area of triangle 1. So this equation is true. This equation is true. Area of triangle 1 plus area of triangle 2 plus area of triangle 3 is equal to area of the whole triangle ASD. When you put together the areas of triangle 1, 2, and 3, area of triangle 1 plus area of triangle 2 plus area of triangle 3. Okay, so the sum of the areas of these three triangles is equal to the area of the whole triangle ASD. So this is the equation with which we are going to find the length of the string each of the boys have. The length of the string is AS. The string will be stretched. The boys are sitting on a boundary. That string will not go like this. That string will not go like this. You understand? You know, when you're playing, you keep the string stretched, right? The string in their hands, it's stretched. That does not make a curve. The string does not go like a curve like this. The string is AS is the length of the string between A and S, that is between Ankur and Syed. SD is the length of the string. They're playing, right, with a toy telephone. Each of them have a toy telephone. So there's a string connecting the phones. AS is the length of the string between Ankur and Syed. SD is the length of the string between Syed and David, and AD is the length of the string between Ankur and David. So what are we doing? We're trying to find the length of the string of each phone. And we know that the strings are of the same length because ASD is an equilateral triangle. Okay, so we have to find the length of the string. And we're going to find that using this equation. This is the equation. Area of triangle 1 is equal to area of triangle 1 plus area of triangle 2 plus area of triangle 3 is equal to the area of the whole triangle ASD. We're going to use this equation. Now, how do we find the area of triangle? Okay, we're going to use this equation to find the length of the string each boy has. Now, area of triangle 1. What do we know about area of triangle 1? The OS is 20. This is 20. This is also 20 because radius. This side we don't know. So that's what we have to find. No, SD. That's what we have to find. A. Similarly, here in triangle 2, one side OS is 20, the other side OA is also 20 because radius, and the third side we don't know. It is A because AS is equal to SD. Or let me say ASD is an equilateral triangle. So we'll call each side A units. ASD is an equilateral triangle. So everywhere it's A. And the third triangle also, if you see, the sides are 20, 20, and A. So when you look at the three triangles, 1, 2, and 3, the sides are the same. The sides of triangle 1 are 20, 20, and A. Triangle 2, 20, 20, A. Triangle 3, 20, 20, A. So they'll have the same area when their sides are the same. So if you try to find the area of these three triangles using Heron's formula, the three sides are 20, 20, and A. So you will get the same area. You'll get the same area. Because their sides are the same, 20, 20, and A. They're identical triangles. They're the same sides. SSS rule, they're congruent. Okay, so you don't have to find the area of triangle 1, triangle 2, and triangle 3. All the three triangles have the same area because they have the same sides, 20, 20, and A. So step 1, we are going to find the area of triangle 1, any one of the three triangles. So say area of triangle 1 using Heron's formula. We'll not get a numerical answer because there is A which is unknown. You will not get a numerical answer, you will get something in terms of A. Now, do you agree that thrice of area of that is okay? Let me not say thrice. So you get something for area of triangle 1. So the same as triangle 2, the same as triangle 3. So now you've got the areas for these three triangles. Next is to find the area of triangle ASD. What do you find the triangle area of the triangle ASD? It's an equilateral triangle. What's the formula to find the area? Root 3 by 4 side square, A square. Root 3 by 4 into side square, so A square. To find the area of the whole triangle ASD, it's an equilateral triangle. So root 3 by 4 into side square, root 3 by 4 into A square. Equate these two. And you will find when you work this, you will be able to find the value of A. And the value of A is the length of the string each boy has. All right, children. I'll just give you some time to breathe because I don't want to repeat the explanation. I'll just give you some time to breathe. You can just have a look at this. Having, had the explanation once. There might be slight changes in what I said, but the idea will be the same because this I've worked it long ago. So here I said 1 to area of triangle 1 plus 2 plus 3. But see, I've here the 3 triangles have the same area. So the area of the whole triangle is thrice the area of one of the small triangles. So you understand that. Area of one triangle is equal to thrice the area of, so area of the whole triangle is 3 times the area of the small triangle. Yeah, go through this. Please read, children. When I say go through, you're supposed to read from here, R case, and look at the figure. When you read R case, you must look at the figure R case D, RKD. Look at the figure. Just get back, children. All right, children. So you can see except for that thrice, I think the other things are just as we discussed. So I told you the three arcs are equal, so their corresponding chords are equal, which makes ASD an equilateral triangle. We need to find the length of the string AS, or I've just put a slash here, or SD or AD. So area of triangle AOD, this one is equal to area of triangle AOS is equal to area of this triangle, because all these three triangles have the same sides 20, 20 and A. So that means the area of the whole triangle ASD, the area of the whole triangle, that is the area of the equilateral triangle ASD, is equal to thrice the area of triangle AOD, or you can say AOS or SOD, any one. The area of the triangle, the area of the equilateral triangle ASD is thrice the area of triangle AOD. Area of triangle, so how do we find the area of triangle ASD? ASD is an equilateral triangle. We understood that. ASD is an equilateral triangle. To find the area of an equilateral triangle, the formula is √3/4 into side square. So √3/4 into A square. You can see it here, √3/4 into A square. Because we've called the side of the triangle A. If you called it B, then it will be √3/4 into B square. Okay. So we found the area of the, meaning we got the expression that represents the area of the equilateral triangle ASD. Next is to find the area of the triangle AOD. AOD. Then, okay, so next is to find the area of the triangle AOD. AOD, area of triangle AOD is found using Heron's formula. Heron's formula. So you can see 20, 20A. 40 plus A is a semi-perimeter. Area of triangle AOD is equal to root of S. This is S. S minus A. So S minus B will be the same thing, no? So I've put a whole square here, meaning 2 times into S minus C. S minus C. The sides are 20, 20 and A. So it will be S minus A. S minus A is S minus 20 and again S minus 20, right? So I've written S minus 20 the whole square. See children, this is S. All right, this is S minus A. Again, this will repeat, right? S minus B is also, another side is also 20. So I've written S minus A, the S minus 20, that is 40 plus A by 2 minus 20, the whole square. Then S minus C, 40 plus A by 2 minus the third side A. Children, is this clear? Is this one clear, children? You write it 2 times, otherwise you don't use whole square. Write it again. S minus A, S minus B, S minus C. Write it 2 times. Can I proceed, children? See, I'm not forcing you to say that, yes, you understood. You have 2 options. You can say, yes, I understood. No, I have not understood. You are not clear. You have both the options. Unmute and say one of the 2. Yes, you understood so far. No, I did not understand anything. Yes. Please answer one of the 2 children.
Ma'am, understood.
Yes, the others understood. Shreyas, Kanishka, Nikita, Satvika, Deepika, Hitesh. Hitesh, why suddenly you're active? I should say overactive. And suddenly you're underactive. What happens? Hitesh, Arav, Ananya, Deepika, Kanishka, Nikita, Satvika, Shivani, Shreyas, Tarun and Tarun Ishwaran. See, only one response. Shreyas says he's understood so far.
Ma'am, yes, ma'am.
I'm surrounded by in a noisy place.
Okay, okay. Kanishka has understood. All right. Somebody else answered. Okay. So normally we say majority wins, now minority wins. Let me proceed. Okay, so far I assume all of you have understood. So now 40 plus a by 2 you can see, and here I've taken up the LCM. So it will be 40 plus a, 2 into 20 is 40. LCM, children, the whole square, by 2 the whole square. And here also LCM 40 plus a minus 2a by 2. LCM. So you can see this 40 plus a by 2, and here 40 minus 40 will get cancelled. So a by 2 the whole square, a by 2 the whole square. And here 40 plus a minus 2a is minus a. So 40 minus a by 2, 40 minus a by 2. Now if you look at the denominators, there is 1, 2 here. This is 2 square. Okay, let me tell you like this. A by 2 the whole square, right? So it's a by 2 into a by 2. So one of it will come out of the square root. A by 2 comes out of the square root. A by 2 the whole square. A by 2 the whole square. 1 a by 2 comes out of the square root. And here the denominators 2 and 2. Of the 2 2's, 1 2 will come out. Of the 2 2's, 1 2 will come out. So, but the 2 is in the denominator, so it's 1 by 2. So you need to write it as 1 by 2. So 1 by 2 of these two 2's, 1 2 comes out, so 1 by 2, and then 2 a by 2's we have, so 1 a by 2 out. Now what remains under the square root is 40 plus a in the numerator and 40 minus a. So it's like a minus b into a plus b, which is a square minus b square. 40 square minus a square, which remains under the square root. Which remains under the square root. See, you can, it's multiplying the numerators, see now under the square, you can look at them separately, like 40 plus a by 2 is like half into 40 plus a. You can take the denominator separately. See, I'm talking about this half, how this half comes out. So this 40 plus a by 2 is nothing but half of 40 plus a. Here there is half of 40 minus a. So there are two halves, one half comes out. This 40 minus a by 2 is half of 40 minus a. So this is, look at this one as half of half into 40 plus a. This one is half into 40 minus a. So there are two halves, one half comes out of the square root. There are two a by 2's, one a by 2 comes out of the square root. And then what is left under the square root? 40 plus a and 40 minus a, which is a plus, which is of the form a plus b into a minus b, which is a square minus b square. All right. Now we've got the area of triangle. That's one of the small triangles. We have found the area of one of the small triangles, AOD. Now we know that this is the, see, we are working with this equation, area of triangle ASD, that is area of the whole triangle, the equilateral triangle ASD. Area of this equilateral triangle is, this is the equation. This is the equation with which we are going to find the value of A. With the help of which we are going to find the value of A. The area of the whole triangle ASD is equal to 3 times the area of the small triangle AOD. That's what we constructed. See, here itself we realized. Here we realize that this is the equation which is going to help us to find A. So according to this equation, you need to find the area of triangle ASD. That you don't have to find, no, because it's an equilateral triangle. ASD, you can see it's an equilateral triangle. So root 3 by 4 a square. Then you'll have to find the area of triangle AOD. That's what we found here. All this is area of triangle AOD. All this is area of triangle AOD. Using Heron's formula. So now this is the equation. Area of the whole triangle ASD is 3 times the area of the small triangle AOD. So root 3 by 4 a square is equal to 3 into children, because area of triangle AOD is this expression. So 3 times that expression. 3 times, you can see 3 times that expression. Right. So next what happens? What happens next? 4 and 4 on either sides gets cancelled. And then this root 3 and here becomes root 3. Because 3 is made up of 2 root 3's. 3 is made up of 2 root 3's. 3 is root 3 into root 3. Let me do it again for you. See here, this 4 and 4 on either sides gets cancelled. Then root 3, and there are 2 root 3's in 3. So one root 3 gets cancelled, the other root 3 remains. And then this a and a square. So 1a remains here. So you have a is equal to root 3 into root of 1600 minus a square. In order to get rid of the square root, we need to square on both the sides. So on squaring, we get a square is equal to this one. When you square it, it becomes 3. This, when you square it, the square root is eliminated. So it becomes, it's free of the square root now, because you've squared on both the sides. Both of them get free of the square root symbol. So you can see a free 3 and a free 1600 minus a square, not under the influence of the square root. Now, what to do? A square is equal to 3 into 1600, 4800, 3 into a square, or 3 into minus a square, which is minus 3a square. So transpose minus 3a square minus 3a square here plus 3a square. So it becomes 4a square is equal to 4800. A square is equal to 4800 by 4, which is 1200. So that means a is equal to a square is 1200. We need to find the value for a is equal to square root of 1200. So you can write this as 12 into 100. You can write this as 12 into 100. You can write this one as 12 into 100. So 100 is 10 square. See, children, this is your style, you know. You can find, you should express this one as a mixed surd. That's all it is. The idea is to express it as a mixed surd. 1 second. Sorry, children. I have to excuse myself a few times. Yeah. So the thing is, you'll have to write. You'll have to express the square root of 1200 as a mixed surd. You do that, whichever way is comfortable for you. I have written 1200 as 12 into 100. Then 12 I have factorized 2 square into 3. And this 100 is 10 square. So 2 2s, 1 2 comes out. 2 10s, 1 10 comes out. 3 remains under the square root. So it's 20 root 3. So the length of the string of the telephone, the toy telephone, each boy has is 20 root 3 meters, not centimeters. It's meter everywhere, children. It's meter everywhere. Is it clear, children?
Yes.
Class use emoji. Raise your hand. Deepika, Kanishka, Shreyesh, Shivani, Ananya, Tarun, Nikita, Satvika, Hitesh. Tarun Ishwaran, Narav. Arav and Tarun Ishwaran. Pranav Rajan. Arav, are you there? Tarun Ishwaran. Okay. You had gone away to drink some water, is it, Tarun?
Yes, ma'am.
Okay, I was right. Okay. All right. Is it understood, children?
Yes, ma'am.
Yes, ma'am.
I think there's a thumbs up emoji. I haven't had a look at the emojis at all. Yeah, there's a thumbs up emoji. Yeah. Oh, see, I believe 5 and 6 are important from your examination point of view. So I normally don't request children to do all this, but for 5 and 6, just show a thumbs up if you've understood.
Ma'am, where's the thumbs up emoji?
Ma'am, where is the thumbs up option, ma'am?
You can see it here. No, see, can you see it on my screen?
Yes,
Mm.
ma'am.
Ma'am, but it's not in our screen.
Yes, ma'am. We can't use it.
Okay, no problem. See, Shreyas. Okay, lower your hands to say that you've understood. Lower your hands, children, to say that you've understood. Okay. All right, fine. Please take a screenshot. Kindly practice 5 and 6. It's important. Please practice 5 and 6.
Okay, ma'am.
Yeah. I've repeated the explanation a few times to make it easy for you to revise. So that it's easy for you to revise. So now it's almost like you've memorized the procedure. Practice it, you can remember. All right, children. So that's it for today's session. Thank you so much.
Thank you, ma'am.
Thank you, children. Thank you.
Thank you.
Thank you.